Okay, hi. It's lovely to see all your faces after all of that time. I really missed you guys. All right, so I was going to have like a clever segue, but I don't have one. Let's just jump right in. So the theme of this conference, it seems to me, is LiveView. I think we've got almost exclusively LiveView talks stacked up. I would love to see a show of hands, folks using LiveView in production. Almost everyone. That is so cool. So I'm going to be kind of preaching to the choir here in this talk where I tell you a little bit about what I see as some of the secrets to unlocking widespread LiveView adoption. Because what I think we've seen so far is a very respectable, maybe even a little bit thrilling amount of LiveView adoption. But I think that we can do more, and I think that more is right around the corner. So I'm going to talk about launching widespread LiveView adoption. You basically already know all these things about me because I've now been talking to you for several minutes, but I'm Sophie, co-author along with Bruce Tate of Programming Phoenix LiveView. Shameless plug, get your copy today if you haven't already. I also co-host Beam Radio with a really fabulous group of people. I'm an engineer at GitHub where, before you ask, we sadly do not use Elixir, but if you want to talk to me about reading Azure documentation all day, I'd be happy to talk about my day job. I also own a dog who is super normal. This is just a totally normal way to sleep on a couch for a dog. Yeah, cool. All right, so something that you guys already know, as we've seen from this show of hands, you love LiveView. We love it, it's great. These are just some of the reasons why I think that the people in this room have probably experienced all of these benefits. It makes you very productive. You're keeping your brain firmly on the server side, even when you're testing. It lets you build sophisticated, interactive UIs really easily. You can even pull in PubSub for real-time features with like 2 additional lines of code, which we absolutely love. And it brings the concurrency and the fault tolerance of the Beam to your typical single-page app, which are features that you're absolutely not going to get if you're working with a pure front-end framework like React, let's say. So we're sold on LiveView, the people in this room, and I think, again, the people in this room demonstrate that LiveView adoption has been really encouraging. A lot of people are using it in a couple of different ways. So this is sort of anecdotal sense that I've gotten just from talking to people who are using LiveView. I also tweeted out a little survey that I asked people to fill out. So this is just sort of my anecdotal sense of how LiveView is being used currently. I think we're seeing a lot of companies that are already using Elixir and Phoenix starting to reach for LiveView. I've also seen a lot of consultancies, particularly smaller consultancies, start to use LiveView for really fast prototyping for their clients. It's quick, it's efficient, it lets you, get stuff to your clients and make money quickly and then move on to the next thing. And I've also heard of a lot of people using it for internal or like admin-facing tooling. I think that's a pretty common way to sneak new technologies into your organization because it's kind of low stakes. You might not be able to convince your EM to adopt a brand new framework for like something really big and important and customer-facing, but they might give you a little leeway to bring it in for like an internal tool. So this is all great, but, and there is a but, there are still some Elixir companies out there that are hesitant to adopt LiveView. And I would say that we're not really seeing LiveView drive Elixir adoption. In other words, I don't really think we're seeing people who are not using Elixir decide to bring in Elixir because they are desperate to get to LiveView yet. So I want to talk about what's standing in the way. Why hasn't this kind of adoption happened yet? And this is what we're going to go through today. I want to tell you about what I see as the common LiveView adoption blockers, the reasons why we're not seeing this kind of widespread adoption just yet. I want to tell you how I think LiveView, especially in recent releases, has knocked down every single one of these blockers. And then I want to tell you about what I think is going to happen next. All right, so we're going to start with some of these common blockers. And the first one is around security, securing your LiveViews. And I'm going to tell you a little bit about the problem that this presents, or presented until very recently. So you're probably already securing your LiveViews with auth plugs in the router. You're putting those plugs before your live routes, just like you would for your regular static HTTP routes. Check, you think you're done. And this is something that I actually didn't realize you had to do until there was a fix for it, or like a better way to do this. I didn't really realize, but when you live redirect between LiveViews, I did know, and you may know, that you're reusing the same socket connection. So that's what's so great about the live redirect. That's why it's super snappy. You're not starting a new HTTP request. You're reusing the same WebSocket connection. But if you're not using a brand new HTTP request, you're not going through the router again. So any auth plugs that you put before your live routes in the router are just totally ignored if you're live redirecting between live routes. So you actually need to secure your live views both in the router for when a user navigates directly to the live route, but you also need to ensure that those live views are authenticated and authorized when they mount every time in case of live redirects. So this is certainly possible for you to do on your own. You can take the auth logic that you had in your plugs and you can just kind of plop it into all of your mount functions and all of the live views that you want to live redirect between. But we hate that because we're developers and we're lazy and we don't want to replicate our code. We want it to be nice and clean and neat and easy. And in recent versions of LiveView, I think this is probably going back to the fall, we now have a solution for this. And the solution is the shared live sessions API. So you use live sessions to group your live routes in the router, and then you can specify that there should be a shared on-mount callback function that gets invoked before any of the live routes in that session block are mounted. So basically, you set up your router like this, and you have your live session, and let's say you've got a bunch of admin routes you want to group into an admin live session. You specify that when any of these live views mount, we're going to call the user auth live modules on mount function with the first argument of the admin atom, and then you can throw some auth logic in there. The details of this are not important, super high level, we're checking if the user is an admin. So what are we seeing here? We're seeing that you don't have to teach your live view how to share auth logic across live redirects. You just have to tell it what auth logic it is sharing. And I think this is a really common pattern that we've already seen in LiveView and that we're going to see again and again as I talk about each of the obstacles that LiveView is now knocking down. And the pattern is this. The framework of LiveView abstracts away all of the tedious, repetitious, kind of hard parts, and all you really have to do is be on the hook for implementing the specific logic that your business, your feature, your application dictates. LiveView takes care of all of the friction parts and just exposes to you the levers that you as a developer need to pull to customize the behavior of your application. And we're going to see it, as I said, again and again as I talk about all of these obstacles. So another obstacle that I heard from people who were hesitant to adopt LiveView, even companies that were already using Elixir and Phoenix, was the problem of state recovery. And I'm going to tell you a little bit about that problem right now. So what happens during a deploy or when a LiveView terminates for some other unexpected reason? You shipped a bug, the LiveView crashes, the LiveView stops, that WebSocket connection is killed, a new process fires up, and until recently, that would mean that any ephemeral state that might have been going on in that LiveView or being held on the client side is now gone. So if you were, like, let's say you have a super complicated, like, multi-stage form on your LiveView, user maybe got through 9 of 14 steps. We all wish we didn't have to make a 14-step form, but sometimes we find ourselves building a 14-step form. And then someone deploys, you know, we all work in modern organizations, CI/CD all day, every day. Someone deploys, user on step 9 of 14 loses steps 1 through 9. That is completely unacceptable. You certainly would not want to ship a product that behaves in that way. And that's no good, right? We can't have that. Until recently, I think this again was a development that came out maybe in early fall. But basically, LiveView has an auto recovery feature that guarantees that your form state is restored if the LiveView disconnects or crashes, and you have to do exactly 0 things to get this working. This is just now baked into the framework for you. So when the LiveView connects, the LiveView JS framework on the client side is going to just automatically invoke any of the Phoenix change events that you've attached to forms on your page, and that is going to give you form recovery for free. So for that most basic form of form recovery, you have to do absolutely nothing. But if you need more, if you need some custom state restoration behavior, maybe your 14-step form is really complicated and there's some really fancy things that happen on the server side to transform that state when it comes up from the client, LiveView once again exposes the levers that you can pull to customize that behavior. So there is a new LiveView DOM element binding. It's called Phoenix Auto Recover, and it allows you to trigger a custom event when the LiveView mounts. So instead of just assuming that the Phoenix change event will fire on mount, you can also attach this Phoenix Auto Recover event to any elements on your page. That will fire for you when the LiveView mounts, and then you can implement custom handlers on the server side to do whatever fancy state restoration you might find yourself needing. So I want to dig into this a little bit with a little bit of an example before we move on to the next blocker. And this is the example of using this new DOM element binding to restore state. So it basically would require you to store your complex state on the client side. So maybe you're taking your state out of that form and you're putting it in something like local or session storage. then you are going to, actually my bad, I misspoke. This is another option for state recovery. So the Phoenix Auto Recover will fire for you for free when your LiveView mounts, but you have another option to restore LiveView state from the client. And you can take your LiveView state, you can put it somewhere in browser storage, right, local or session storage. You can ensure that when the LiveView connection initializes, that it includes that state from, let's say, session storage in the connect params for when the LiveView mounts. And this is basically what that looks like. This is a very small update to the app.js file that already gets generated for you for free when you generate your LiveView app. So like the second 2 lines should look super familiar, and that first little bit of it is the only thing that's different, and it basically involves you pulling something out of session storage that you had put in there at an earlier point in time, and those are the params that you send up to LiveView when it connects. And then the last piece of that is that you just teach your mount function to pull out those params and do something with them. And you can use the get connect params function, which LiveView exposes for you. It'll pull out whatever you stored under, in our case, the restore key of params. And once again, you get even more advanced, sophisticated state restoration from the client up to the server. So with auto recovery, the LiveView framework handles, I would say 90, maybe 95% of your state recovery needs. And then between custom recovery events and the client state restoration pattern, LiveView exposes the tools to you that you need to get that extra 10% of customization. And this is the pattern that we're seeing again and again. LiveView takes the hard parts, but exposes enough of an API to you to customize on top of that. All right, so another blocker. File uploads are not quite as new as some of the other things that I'm discussing in this talk, but up until I would say maybe about a year ago, there wasn't a super neat and easy solution for file uploads in LiveView, and I think that we would all agree that file uploads are a pretty essential must-have of any modern web app. If you can't have an easy file upload solution, I would think it would be super valid for you to say, you know what, this framework is not the one that we're going to pull off the shelf today. But now with the file upload API, you really don't have to write like any code to do even very fancy things with file uploads. So the LiveView Upload API supports interactive both direct to server uploads and direct to cloud file uploads. You can say, hey, just send this straight up to S3 without writing that custom code yourself, which, you know, again, we're lazy. I think that's great. So I'm just going to tell you a little bit about how it works. We're not going to get too into the nitty-gritty code details, but there's 3 steps, 3 ingredients to leveraging the LiveView File Upload API. The first thing is that you need to specify the upload specs in your LiveView. You're going to tell your LiveView when it mounts that it should expect to receive and track some uploads, and you do it with the live upload 3 function. So here's your mount function, and you're going to use allow upload. You're going to tell it the name of the key and socket assigns to track upload data under. And then you can pass in a number of different specifications. I'm just using this basic example here, where I'm saying that I'm only going to accept live uploads that are JPEGs. And from this, you actually get validation on those uploaded files for free. That's also baked into the framework. So what happens when you use allow upload? LiveView adds a new key to socket assigns called uploads, and under that key, you then get a nested key of whatever uploads you're deciding to allow. So you can allow as many uploads as you want in a particular LiveView. I could allow cover image, I could allow thumbnail, whatever, and then under socket assigns uploads, you would see cover image, the details of the cover image upload file that LiveView is going to track for you, thumbnail, the details of the thumbnail file that LiveView is going to track for you, and so on and so forth. And all of that happens for free just because you called allow upload. So that's pretty much what I just got into. LiveView adds an assigns of at upload, and it's going to track the details of the uploaded file under that. And you can then introspect on socket assigns uploads, in our case cover image, and you can get data about the progress of the upload, and you can get data about any validations that have failed on that upload, in our case if somebody tries to upload something that is not a JPEG, for example. And you can also see any errors that occurred and render them to the user. All of that gets tracked for you and added into socket assigns. All you have to do is pull it out and display it in whichever way that you want. So you've added the upload specs to your LiveView. The next thing you're going to do is add just a little bit of markup to your template so that a user can attach a file. You can do this with the live file input function, or you can do it with the Phoenix drop target DOM element binding. So users can drag and drop elements, or with the live file input, they just get a button that they can click and the file selector comes up. So again, you're not implementing the HTML or the JavaScript that supports uploads. You are writing, what is this, 1, 2, 3, 4 lines of code to get all of that working. It's pretty powerful. Or 2 lines of code for a drag and drop. The final bit of this is to, well, let's actually stay in the markup land. Let's stay in markup land. So when a user starts to upload a file, as I said earlier, all of the details about that upload get tracked for you for free in socket assigns upload, in our case cover image. So then you can pull that data out and do stuff with it. You can display an image preview with the live image preview function that you get for free from LiveView. You can display upload progress with by calling progress on the uploaded file that you're going to pull out of socket assigns. You can display upload errors by calling, that's actually a little helper function that I wrote, but you can introspect on the errors and display them to the user. Once again, you're looking at, what is this, 4 lines of code, 6 lines of code for an image preview, 4 lines of code for progress, 6 lines of code to display errors. You're not in charge of implementing the details of how LiveView displays progress, displays errors, displays previews. You're just responsible for telling LiveView what to display, which is pretty neat. So the final piece of our 3-step live upload puzzle is teaching your LiveView what to do with the uploaded files, how to save them. And LiveView exposes a function for us to do exactly that, and it is called consume uploaded entries, and basically it allows you to iterate over your uploaded files and do a thing with them. I omitted what that thing is because, again, the details are up to you and your business. It's upload to S3, it's upload to whatever else people upload files to. I don't do a lot of file uploading. But again, LiveView doesn't care. You don't have to teach LiveView how to handle file uploads. You just have to teach it what to do once you've got your hands on those files. And that, I think, is, again, this pattern that we're seeing again and again. You don't have to tell LiveView how to upload files. You don't have to tell LiveView how to display and handle the HTML and JavaScript for file uploads. You don't have to tell LiveView how to validate files, track progress, track errors. All you have to do is take that information that LiveView makes available to you, display it to the user in a way that suits the needs of your business, and save that content in a way that suits the needs of your business. All right, 2 more blockers, code organization, and then we're going to get to my favorite one that I'm really excited to talk about, which is custom JavaScript. So I want to talk a little bit about code organization. This is something that I heard a lot from people who would tell me that they were hesitant to adopt LiveView within their organization. And basically, it was just this feeling that you were going to end up with code that was really gnarly and hard to maintain. And I think the analog here, if anybody has like a Rails background, for example, would be the fat controller syndrome. You can end up with these LiveViews that are super long, have a ton of event handling. They can have these corresponding templates that's even, let's say, hundreds of lines of HTML. There's nothing technically stopping you from doing that, but I do think that LiveView does have a solution for it. And the solution is components. You're going to wrap up distinct behavior in live components, and you're going to encapsulate common reusable markup in function components. And using these 2 strategies together helps you create really neat, composable, layered UIs that are clean and single purpose and easy to maintain. And another nice thing about components is you get this ergonomic component rendering syntax. So when you actually do string them all together, let's say in that top level LiveView that puts all your components together, it's really readable, it's easy to write, easy to maintain. So I do want to look at an example. And the example is going to come from this little app that I put together that's like a library app. And you can see in this GIF that we have got a user that can click the little search icon and it shows or hides what is actually a pretty complex form. So we've got this overall live view, we've got the form for the search, and then we've also got this little search icon. And this is how it all gets layered together with the help of components. The Books Live Index is the main live view that's mounted here that you're seeing in the page. Then we've got the search component that contains the form. And then within that, we actually have a small, teeny tiny single-purpose function component that shows the search icon and controls the behavior of clicking on that icon. So we would render the search component, which is a live component, which means it handles behavior as well as markup. We're going to render it from that top-level live view. And this is what that syntax looks like. You call the live component function, you tell it what module you are rendering there, and then you pass in some of these attributes that end up becoming the assigns of that component. And then that live component becomes the one that handles all of the nitty-gritty behavior of that search form. So just going back to that GIF for a second, it's a little quick, but you can kind of get the idea. There's a lot going on in that form. There's the author, there's the title, there's a slew of categories, there's this checkbox for whether or not a book is available. So all the logic around handling the submission of that form is not trivial. It's actually fairly complex. And we can pull it out of this top-level index live view, and we can keep it more appropriately in our search component and just kind of focus it all in one place, make it easy to test, easy to maintain, easy to build out in the future. So then, to kind of return to our overall structure, that search component is going to in turn render another component, which is a teeny tiny function component, just the search icon itself. And this is the function component rendering syntax. It looks very React-y, I think. If you're familiar with React, we call the module name dot the function name, and then we pass in any assigns. And overall, I think layered together, LiveView components really give us the tools that we need to organize our live views in these nice composed layered UIs. And it's really easy to string your components together in different ways that suit your different needs. And it's really readable, it's really ergonomic, and I think that makes it easy to maintain. Before we move on to this final blocker, I want to talk a little bit more about this search icon component and function components in general. Function components also let us wrap up common reusable markup. So in the example that we saw so far with the search form and the search icon, that was like a very specific use case. You might not want to use that search form elsewhere in your application. It kind of really just needs to live on this one page. Ditto for the search icon, maybe you'll use it elsewhere, maybe not. But function components are really neat because you can use them, think of it as almost like a Rails partial. How can I just wrap up markup that I want to use again and again in my application? And we can do that by taking a look at another example. So I want to show you a brief example where we have a function component that is responsible for rendering a Bootstrap style card. So basically, the cards that have, actually I think I have a picture that I wanted to move up and I forgot to move it up. Here we go. Bootstrap style cards. So we've got book reviews from my fabulous, library app here. And the Bootstrap card is, each of these 3 cards here. And we can certainly imagine wanting to use this elsewhere in the app. It's a really nice fit for displaying our book reviews, but it could also be used to display, user contact information, book overviews on some kind of index page. This idea of having a reusable component that you can inject any content into, I think is very appealing and very relatable. So we get to do that together with this little example. So you would define a function that renders some provided content from assigns into the card markup, and that's pretty much it. So we've got our card component module. It uses the Phoenix component behavior, which is what you want to include in your modules that implement function components. And then it's just one simple, still pretty small function called card. It takes in some assigns and it renders some header content, it renders some title content, and it renders some body content. And the render slot functionality is really what I think charges up your function components to be truly dynamic, because you can render any bits of named dynamic content within any parts of your function component. I'm going to show you what I mean by that by showing you the component in action. So we call on the card component card function component. Yep, that's actually correct, even though it sounds like a tongue twister, with the opening and closing tags. And then we use the header tag to specify what the header content is, title tag to specify the title content, body tag to specify the body content, and then each of that bit of inner content gets injected where we say render header, render title, render body. Super, super dynamic. So these are called named component slots, and they allow us to dynamically render different pieces of content into or injected into your function components markup. And we can also yield variables back up to the caller for even more control. And that's what's going on here when we are specifying this let review and using review here. I don't want to get too into the details of that right now, though. And this is the result. We have this reusable card component that we can pop anywhere throughout our application. We can put anything in the header, anything in the title, anything in the body. Okay, so this brings me to our very last blocker, which is integrating custom JavaScript. So another thing I would hear a lot from people who are hesitant to reach to LiveView is this idea that you start to hit up against these barriers when you have an application that needs a lot of custom JS that you would conceive of as being very front-end heavy. And don't get me wrong, I do think there is a line that you would draw where LiveView stops serving you. If you're creating like a pure in-browser game that needs to run at scale, maybe LiveView is not the choice for you, although I know I have seen people who've done a lot of games with just LiveView. But that line I think has been pushed further out. I think there's so much more you can do with LiveView and custom JavaScript because of some actually quite new things that have come out in more recent releases of LiveView. And I want to talk a little bit about that now. So we now have a new feature called JS bindings, or you'll also hear it referred to as JS commands, the JavaScript command interface for LiveView. Basically allows you to execute utility operations fully on the client, and you can integrate it really neatly with JavaScript hooks to invoke even really complex JavaScript in response to user interactions. I want to focus on this first piece of it first, this idea that you're executing utility operations fully on the client, because this gets at another reason why I think people are sometimes hesitant to reach to LiveView. So if you are doing something super common and normal, like showing and hiding a modal, if you're doing it without any JavaScript, even in LiveView, before the JS command interface, you would probably do something like this. You might have an attribute in socket assigns that indicates whether or not the modal should be shown or hidden. And then you might say when the user clicks, open or whatever, I'm going to send an event up to the server. I'm going to change that data point in socket assigns, and then I'm going to let it go back down to the client and re-render. So you're essentially round tripping to the server for one of the most common JavaScript interactions that exists. And I can understand why people would be reasonably hesitant to say, I'm going to reach for this framework that forces me to round trip for the server for something that JavaScript has been doing for me just fine for decades. But JS commands takes that consideration away because it consumes a lot of these really common JavaScript interactions, bakes them into the framework, and allows you to just take advantage of them without writing that JavaScript yourself. So I want to take a look at an example. Back to our little showing and hiding the search form when a user clicks on the search icon. We actually have implemented this with the JS toggle function, which is part of the new JavaScript command interface. And the JS toggle function, as you can probably guess from its name and from the GIF that I have now showed you several times, toggles the display attribute of an HTML element. Here's how it works. So this is the search icon function component, and all it does is render a little bit of heaps that has a Phoenix click on this Bootstrap icon search. And the value of this Phoenix click DOM element binding is the JS toggle function. And all we have to do is tell the JS toggle function what element it's targeting. In this case, we're saying toggle the showing and hiding of the element with the ID book search form. You can imagine that the book search form has the ID book search form. And that's really it. So there are many more JS commands that are available to wrap up common interactions like adding and removing a class. You've already seen showing and hiding an element. You can add temporary transition elements for animation, which actually integrates really nicely with Tailwind because you can add and remove Tailwind classes that do fancy transition things, and so much more. And all of that happens completely on the client side. So you get all the benefits of LiveView. You still get to hang out mostly on the server side, but doing those simple everyday things, showing and hiding a modal, showing and hiding a form, can still happen purely on the client, and LiveView is going to do it for you. You don't have to tell LiveView how to show and hide a modal, a form, whatever. You don't have to write that JavaScript yourself. You just have to instruct LiveView what to do. When the user clicks the search icon, please show and hide that target element. So LiveView is wrapping up the nitty-gritty details in the framework, and it's just exposing only the tools that you need to add in your own custom functionality. JS commands can do even more than this, though. This is kind of just scratching the surface of what you can do with JS. You can also push events to the server in response to user interactions, and you can dispatch events down to the client so that you can have just custom JavaScript hooks that respond to those. So you could imagine doing something like a Phoenix click that does a couple things. Maybe it invokes a JS toggle so that you have an interaction that happens right away on the client, but then maybe you also push an event up to the server so that the server can do something else a little bit more persistent in response to that event. And then maybe after that, the server pushes something back down to the client that a hook can respond to and implement lots and lots of fancy JavaScript from there. I'm just keeping an eye on the time because I think what we're going to do is I'm going to show some of this example and then we'll probably skim over the rest of it. But let's say that I wanted to make our search toggling persistent across page reloads. I'll show you what I mean by that. This should be a video. Excellent. Okay, cool. So I want it to be that when I click this, the URL updates such that when I refresh the page, the search is already visible, like this kind of sticky behavior here. But I also want to make sure that the showing and hiding of the search form still happens purely on the client. I'm not trying to round trip to the server, but I also want something to happen server side, which is that that URL changes so that I can get this persistent page refresh behavior. Nope. I would like to go to the next slide, please. Cool. When the user clicks the search icon, we're going to toggle the search form on the client, and we're going to push an event to the parent LiveView. And here's how we do it. We do it with a nice, neat Elixir pipeline. So now on Phoenix Click, we call this helper function. And by the way, I could put this inline in the Phoenix Click. I just extracted it for readability. We are going to push an event called toggle book search to the parent, the target that we passed in socket assigns. And we're also going to call the JS toggle function so that we can ensure that the showing and hiding of the target element is happening quickly and easily purely on the client side. So then we would simply teach the parent LiveView to handle the event that we're pushing up by updating the URL to include the search query parameter. And this is the part where I'm not going to get too much into the details here, but we've got our custom event handler, and based on some attribute in socket assigns, it's going to do a push patch to update that URL for us. And this is the part that I'm skimming over because we're running out of time. Okay, cool. So, like I said earlier, this just scrapes the surface of what you can do with JS bindings, and I really, really recommend checking out Chris McCord's Live Beats project that some of you guys may have read about or seen. I know he's been tweeting and writing a little bit about it, but it's basically like a LiveView powered collaborative, I think, DJ app. And a lot of that has to happen in JavaScript, a lot of the playing of songs and next song back and all of that. But it is LiveView powered, and the way that he's integrated a lot of custom JavaScript with hooks with the help of this command interface, I think is a great example of just how powerful your front end can be when it is backed by LiveView. So, I'm doing great on time. Earlier versions of LiveView, I think understandably left some people hesitating to adopt. Security was a little bit of a head scratcher. File uploads were kind of a pain in the butt. State recovery, and at least until the auto recovery, was, I think, a real blocker for a lot of people. Questions around code organization made folks hesitant. Awesome. Go, go, go. Questions around code organization made people hesitant to adopt a brand new framework when they weren't really sure where their code was going to go and how they were going to build it out in a way that was neat and clean and maintainable. They didn't really know what the best practices were. All of these things were possible in earlier versions of LiveView, but you were just having to take on more of those responsibilities yourself. You can secure your own LiveViews. You can just duplicate a bunch of logic in your mount functions. You can figure out how to organize your code. You just have to kind of think a lot about it and reinvent the wheel every time. You can upload files. It'll just take you forever to write a bunch of custom code, and the whole point of LiveView is that we don't want to write a bunch of HTML. We don't want to write a bunch of JavaScript. But I really believe that the latest releases of LiveView have answered all of these questions and pretty much knocked down every single one of these blockers. Again and again, we see that LiveView wraps up the details of the solutions to these problems, and it only exposes the levers that you as a developer need to pull to implement your own custom business logic as per the dictates of your application, your feature, or your organization. And this is very much within the spirit of LiveView, right? This is kind of where LiveView came from in the first place. We don't want you to have to be responsible for all of the nitty-gritty channel management and opening that socket connection. We don't want you to be responsible for all of the nitty-gritty of sending events and handling them on the client side. Let's pull that into the framework. That's kind of where LiveView was born, and it's definitely true of the latest versions as well. So that's pretty much what I just said. Moving on. So this kind of last piece that I want to wrap up on, what do I think is going to happen next? I think that we're going to see kind of an explosion of LiveView adoption. I really do. I think that the adoption that we've already seen within the community is encouraging. I think that other organizations and folks out there are going to be able to look to that for a lot of great examples of what you can really do with LiveView. And I think we're going to see companies, not only folks that are already using an Elixir and Phoenix, reaching for LiveView, but I hope that we're going to see LiveView now drive Elixir adoption. I think it is such a compelling choice for a web framework that companies, organizations, and individuals who are not using Elixir at all are going to pull in Elixir because they're going to want LiveView. And that's it, a big pink slide at the end.